Welcome back to Microsoft Build 2017. My name is Joel Narwold, and this is System Performance is a Feature, Understanding System Health Through Telemetry, a continuation of the real-time sentiment built on the Azure IoT stack. For an agenda, we're going to talk about Microsoft Pulse, the real-time voting platform, the technical challenge we faced and how we solved that through structured logging, the basics of structured logging, then we'll dig into Serilog, the .NET library we chose, and then we'll wrap up with lessons learned, resources, and a few things to consider. Alright, so a little bit about me. I'm a full stack developer with the GMR Marketing Digital team dedicated to the Microsoft Pulse project. I've been with this team for the past 2 years, and during that time, I've helped support several large-scale events, including this past year's State of the Union and presidential debates. But what is Microsoft Pulse? Well, 3 years ago, Microsoft partnered with GMR Marketing, an experiential agency with a deep digital and product development team. They partnered with us with the intent of creating a bleeding-edge crowd engagement tool. Now, the goal of that tool was to capture audience sentiment in real time and display the feedback from participants through both live voting and polls. Overall, I'd say we accomplished our goal. We were able to support a myriad of different events and producers, including CNN and Telemundo's coverage of the 2017 presidential race. Microsoft Pulse is broken into two pieces: the producer screen and the second screen. The producer screen is a self-service tool that allows a user to create pulses, surveys, and polls and monitor each of those as they're pushed to the second screen. From their dashboard, producers can gather valuable insights on how many users are viewing their pulse, the number of votes that came in, and how different demographics are voting. You can also grab this information via our external API, which is incredibly useful to some of our partners like CNN, who want to display that information in real time on TV. Now with the second screen, viewers interact with Pulse either on desktop machines or mobile to provide real-time instant feedback. They can then view the sentiment both as an overall number, an average sentiment over time, or broken out by different demographics. This breakdown of sentiment by demographic is also incredibly invaluable to producers, whether they be marketers, broadcasters, or educators. Alright, so now you know a little bit of what Pulse is, but let's get into one of the technical challenges we faced as we built it. So you just recovered from a major site outage. Fortunately, the impact was low. But what do you think caused the problem? And is it just still a theory, or do you actually know what caused it? What do you do? Well, for us, we came up with a plan. The core of that plan was to implement structured logging. This would allow us to monitor the architectural performance and potential problem areas, capture and store user errors, and then recap the Pulse performance over time. This allowed us to see what things were happening in the moment when we needed to better debug, especially during large-scale events, but it would also give us a feel for how our architecture evolved as time went on. But what is structured logging? It's essentially the logging of data in a format that isn't free-form text, but rather structured objects. I think most of us, myself included, are fairly used to standard logging methodologies and text blobs. You format your log and then store it either in a text file, SQL, or some other data storage tool. But while the information might be relevant, it can be difficult to sift through that data and pick out the individual pieces that are actually relevant to what you need. Parsing out multiple IDs or values using a full text search is incredibly slow and error prone, while structured logging is fast and also separate, so the likelihood of error is almost eliminated. Now there are quite a few different benefits for going with something like structured logging. The first, and I kind of already talked about this, is that it eliminates the parsing problem. It means that there's no more tedious sifting through text blobs. It allows you to focus on an individual property or properties that you know you need rather than sifting through one larger chunk. Fields are also preserved for the use in the consuming apps, which means that if you have a specific property you want to monitor on your app, that specific property will also show up in your sync, whether that be Seek or Elk, and I'll kind of talk about those syncs a little bit later. It also introduces a query-based searches within those logging syncs. So again, you can focus very specifically on the item that you need rather than a larger chunk that you're trying to filter. It means that you know that the data you're getting is the data you need. So let's talk about Serilog, which is a .NET framework. It's the one we chose, and we definitely like it. Serilog is a framework that provides logging to files or the console, etc., etc. So it acts in a similar manner to frameworks that you're already used to, but it also allows for parameters to be preserved as structured data. That means you can have objects or text blobs. Now there's several different types of structured data that it supports. It supports simple scalar values, collections, or even objects. Now for us, objects are one of the most important things because it's a lot easier to filter out your data and focus in on very specific things, especially if they're multiple layers deep. I'm going to go ahead and talk about several of the very unique things to Serolog and why we found them so useful. And the first of these is how you log events. So the syntax is more or less just a superset of the standard .NET format strings. So for most of you, you'll already know what that looks like. But if you do a string.format, it's essentially the same exact thing. Now, a few different tips. Property names reside between curly brackets. Again, you'll know this format from the .NET format strings. To prefix property names with an @ or a $, you can control the property serialization. And then you can also use numeric property names to match with the log method parameters. Again, this is very similar, if not identical, to the .NET format string, so it's something you should already be comfortable with. There are many different levels that you can log to with Serolog. The first of these is verbose. So that means you're going to trace the information and the debug minutia. This is essentially the very lowest level of information you need. Realistically, you're not going to want this on in UAT or QA or production. This is very much a developer debugging scenario. The next level up is debug. Debug is designed to control the internal flow and the diagnostic dumps. Again, this is something that's very developer-centric, and you won't often see it on QA or UAT unless you're specifically trying to debug a certain instance. Beyond that, we have the information level. This is the first level that you really want outside observers to see, and it typically contains the most relevant data. This is a general information stream of data that you'll see at all times, whether that be how well something is performing or how many users are on the system. These are just things that are over time going to be useful to you. Once you get past information, you hit the warning. This is the first level of something going wrong. It's potential system issues. It doesn't mean that something has gone wrong yet, but it means that it could be coming down the pipe. If it gets past the warning level, it goes into the error. It means it's a breakdown within the system. It's not yet a critical error, but it's something to be concerned about and something you definitely need to check out. So again, you want to reserve these for very specific things of something going wrong that you need to fix as soon as possible. It's a red flag situation. Now lastly, but certainly not least, is fatal. This means that there's a critical error within your application and it's crashing the system. This is a fire happening. You need to deal with this immediately. So you want to reserve these for very, very, very serious issues. Now keep in mind that these log levels are set by you. So that means you have to choose what's important to you, whether it's a verbose, a debug, or information. Obviously, fatal and error warnings are pretty easy to determine, or at least catch. But the real tricky part becomes what's relevant information for information or debug or verbose. The lower level, the harder it is to determine if it's relevant to what you want based on that level. Now these levels are also important because you can switch them based on your environment. On any given environment, you can restrict the level of logging to a set level, and you can dynamically adapt that level to meet your situational needs. For example, on QA scenario, you may want to see information and above. UAT, you may want to see warning and above. Production, you may want to see critical and above. But as things change, if you see an error in either warning, error, critical, you may want to drop that level down to debug or information to get a little more information on what's happening within the system itself. Once you've determined the proper level for your log, you can then add a source context. So Serolog, like most of the .NET frameworks, will allow you to tag an event with its source, which is generally the class information. Now this is important because it allows you to filter or redirect the event messages based on the source context, which is great when you want to filter out noisy events or selectively write certain events to particular syncs. And again, I'll talk about the syncs a little bit later, what they are and how they work. Another feature within Serolog is what they call enrichment. Log events can be enriched with the properties in various ways. You can dynamically add and remove properties from the ambient execution context, but keep in mind that all push properties will override any existing properties with the same name. This is especially useful when you want to give a log something very specific. So for example, if you are in the middle of voting on a pulse and you want that pulse ID to go with your log, you can add it via the log context. While you can use your own custom log context property, Serolog does come with a couple enricher packages by default. The first of these is the environment, which will get you the machine name and the environment's username, the process, which will give you the process ID, and then the thread, which will give you the thread ID. Now the last feature of Serolog that I want to talk about is something I've mentioned a couple times now, and those are syncs. So syncs are what are employed to store log events in various formats. Now the format many of us are probably used to is file and SQL. But through Serilog, there are actually over 50 available syncs, and they're a mixture of company and community driven. Azure itself has 4: Analytics, DocumentDB, Event Hubs, and Table Storage. And that means if you're using one of those, that's where you're going to store that data. For us, we use something called Seek. And I'm going to give a little bit of a demo of how that works, what it looks like, and why it was so beneficial to us. I've actually got Seek pulled up in the background right now, so I'm just going to go ahead and switch over to that. Now this is the production dashboard of our Seek instance. So all the information here is, I believe, information level and above. One of the cool things you can do here is you can actually hit this auto refresh tab, and it'll update your overall dashboard as new information comes in. It's pretty awesome, especially when you've got an extra screen and you're monitoring things during a live event, just to see the stream of data coming in and not have to always update a new query. So I'm going to go ahead and turn that off. If you want to see your data for a very specific event, you can also go into the date tabs here and select either a date, a time, a range of dates, whatever it might be. And you can also see, as I'm doing this, how quickly that data is being updated here. I mean, it's almost real time. It's incredibly quick, far quicker than you would see if your data was stored in SQL or something like that. But supposing I wanted to see how an individual call was looking and the data within it, I can actually just click on here and it'll give me the object itself. So I can see its app ID, its role instance ID, the environment. The environment's actually crucial to us because when we're fully scaled out, especially in production, we've had up to 9 regions. So this helps us filter out where the data is coming from and if there's a problem in a certain region or if it's overall on a certain component. If I want to read the data itself, I can actually go in here. So you can see that it's stored as an object, and I can dig down over time. So I can see how my SignalR is performing, the connections it has on a given box, and then the overall performance of the box itself, how much free space it has, the total size, stuff like that. So it can help narrow down whether there's an issue on the size of the box or if its SignalR is acting up. It gives me a lot more information on what's happening. Another incredibly useful feature of Seek is the signals. That's actually in the top right corner up here. So the signal is essentially like a quick filter. So we've got a lot of pre-canned ones here that myself and the rest of the team have come up with. You can also create your own. So for example, if you wanted to filter out your data by a certain log level or a certain component, or in our instance, if we're using Seek for debugging purposes, each of us developers would actually add a custom property with our name on it. So you could filter out based on your own computer and the information you're sending into the system. So I'm going to go ahead and grab a pre-canned one here. And now you can see that the only things I'm seeing in my dashboard are log level error and above. So again, it's a great way to quick hit get information. And then last but certainly not least is the query window. That's this little bar right up here. So I'm going to go ahead and flip my signal back to none so I don't have any filters on there. Then I'm going to put a query in here. Now your query can be anything SQL based, and it's essentially how you're going to grab information out of your system. So in this instance, I'm actually focusing on our Pulse Web API so that I can get a better feel for how my API calls are performing, how quick they're taking, or I should say how long they're taking for a specific call. So I'm going to go ahead and kick that off. And I get information here, and you can see based in milliseconds how each call is taking, how long each call is taking. But it's a little hard to get a feel for the information and what it means. They actually give you some pre-canned different graphs. The most relevant of these are the bar chart and the pie chart. So now you can see very easily what calls are taking more time. And then based on how long they're taking, you can decide whether or not you need to spend some time refining those calls or if the time is acceptable. And again, if I flip over to the pie chart, it looks something like this. Obviously, this is only a snapshot of what Seek can do. It's an incredibly powerful tool, and I highly recommend checking it out. If you're working with Seek and for whatever reason you decide you don't like it, again, Serilog does offer quite a number of other options, over 50 to be exact. And Serilog makes it in such a manner that it's very easy to plug and play the different syncs, and you can actually even run more than one at the same time to get a better feel and compare and contrast how each of them works. And now that you've gotten a brief snapshot of Seek, I'm going to go ahead and flip back to the deck. As we wrap up here, I'm going to talk about a few different things. The first of those is the resources. So I added a couple links here to get you started. Serilog, the Serilog syncs that are available, and then our favorite sync, which is Seek. If you don't, for whatever reason, like Seek or don't like the pricing structure, whatever it might be, I highly recommend checking out the middle link. Like I said earlier, there are over 50 different available syncs, So there's definitely something there for you no matter what you might need. In closing, I had a few final thoughts that I wanted to leave you with. The first is to test your logging at scale. No logging solution is perfect, and you may find one that you really love, but it doesn't really perform well in production. So you want to play around with each of them and get a feel for how they're going to perform in the real world. Second is to demo different syncs. As I mentioned a couple times, there are over 50 different syncs, so you have a lot of different options. So don't just start with one and stick with it. Even if you like it, give the other ones a try, and you might find that one you chose after your initial one is even better. And finally, log early and log often. I can't say this enough. The more you log, the better insight you have into your overall system health. And the fact of the matter is, with the 6 levels I talked about for Serilog, it's incredibly easy to filter out unneeded messages until you actually need them. Alright, well that's all I've got for you today. Thanks for watching this presentation, and I hope you enjoyed it and found it helpful. If you have any questions, either about Pulse and how we were able to use structured logging, or how to partner with GMR Marketing, feel free to shoot them over. My email is down below, and I'm more than happy to answer any and all questions you might have.